Hi guys, I thought I'd take a few minutes and go over the free response questions to the sampling distributions test. These are problems that we're going to keep adding to and working with for the rest of the year. So I wanted to make sure you understood each one of them. So just to remind you of the question, the first one was the amount that households pay service providers for access to the internet varies quite a bit, but the mean monthly fee is $48 and the standard deviation is $20. The distribution is not normal. Many households pay a base rate for low-speed access, but some pay much more for faster connections. A sample survey asks a simple random sample of 500 households with internet access how much they pay per month. Let X bar be the mean amount paid by the number of the sample. And then our first part of the problem says, calculate the mean and standard deviation of the sampling distribution of X bar, interpret the standard deviation. So as you can see, I went through and I kind of just underlined in the question kind of important information that they give us. So they told us the mean was $48, the standard deviation is 20, and that the population is not normal. That's going to be important for us. And that our sample size was 500. Okay. Our other key piece of information is this X bar. Okay. The X bar tells us which of the equations we want to use from our half sheet. So X bar represents the sample mean of the sample proportion. So we're going to use these two equations for calculating the mean of the sampling distribution and the standard deviation of the sampling distribution. So on our half sheet, we see that the mean of the sampling distribution is equal to the mean of the population. Okay, the mean of the population, they told us in the problem, was $48. Okay, so the mean of our sampling distribution is also going to be $48. Okay, and then the standard deviation of our sampling distribution is the standard deviation of the population divided by the square root of the sample size. So we have the standard deviation of X bar equals the standard deviation of the population divided by the square root of the sample size. So in the problem it told us $20 was our standard deviation, and the square root of the sample size, we're told our sample size is 500. Okay. That comes out to be 0.894. Okay. The last thing the problem wants us to do is to interpret the standard deviation. Okay? With these problems, because sample size does change what the distribution looks like, remember the larger the sample size, the smaller the variability. Okay, we're going to say in a sample size of 500, the typical distance to the mean of 48 is 0.894. We can just leave it like that. Okay. The second part of the question says, what is the shape of the sampling distribution? You'll remember I said up at the top it was important to note that our population was not normal. Okay? But we know from the central limit theorem that when n, our sample size, is greater than or equal to 30, no matter the shape, of the population, the sampling distribution will be normal. And that's our central limit theorem. Okay, so n, our sample size, was 500. So 500 is greater than or equal to 30. So the sampling distribution is normal. Right? And then the last question with this is C, find the probability that the average amount paid by the sample of household exceeds $50. So anytime you see this probability, we're going to be talking about the normal curve. Okay? And with the normal curve, because we just said our shape is normal, then we're going to take our mean of our sampling distribution is 48. Okay. And it asks us what is the probability that it exceeds $50. So 50 is higher than 48. And if it exceeds $50, that's going to be to the right. So we're trying to find this probability. Okay. So, to do that, we need to find the standard score, or z-score, for this problem. So remember that the standard score, or z-score, is found by looking at your sample minus the mean divided by the standard deviation. Okay. So, the statistic that we're interested in is $50 minus the mean of $48 divided by the standard deviation that we found for our sampling distributions, 0.894. And that's going to give you a z-score of 2.24. Okay, so the standard score, the z-score, is not the probability. We're going to go to table A and go to 2.24. Okay, so 2.2 and then over to 2.04 is 0.9875. Now this is a probability, but remember with table A, all of the probabilities that it gives us is to the left. So instead of this being the probability, we're going to take the probability of the whole, 1, minus the probability of this area to get this area, which is 0.0125. Now, you can leave it like this, or you could move your decimal to the right 2 places to get a percentage of 1.25%. So 1.25% of the sample of households exceeds $50. All right, so that was number 1. Let's go ahead and look at number 2. So an automaker has found that the lifetime of its batteries varies from car to car according to a normal distribution, we underline that, with a mean of $48 and a standard deviation of 8.2 months. The company installs a new battery on a simple random sample of 8 cars. So part A says that we want to calculate the mean and standard deviation of the sampling distribution of X bar for simple random sample size 8. So again, we have this key that tells us which equation that we want to use our X bar. So we're going to use the same formulas that we used in the last problem. All right, so we know that with this type of problem that the mean of the sampling distribution is equal to the mean of the population, which they told us in the problem was 48. Then the standard deviation of the sampling distribution is equal to the standard deviation of the population divided by the square root of the sample size. So it tells us in the problem that the standard deviation is 8.2, and we're looking at a sample size of 8. So our standard deviation is 2.899. And it's important that we keep these decimals here because it's going to make a difference when we get down to doing a z-score. All right, part B, the standard deviation, or interpret the standard deviation from part A. So again, we're just kind of using that sentence stem again in a sample size of 8. The typical distance from the mean of 48 is, and then we state our standard deviation. I like kind of using these sentence stems over and over. It might even be handy if you jotted it down maybe on the back of your half sheet. All right, part 3, find the probability that the sample mean life is less than 42.2 months. So we're looking at probability, so I'm going to draw a normal curve. My mean is at 48. I'm interested in the value 42.2, and the problem says less than, so I'm going to shade to the left. Okay. Finding my z-score so I can find a probability. I'm going to take the statistic I'm interested in, 42.2 minus my mean, 48, divided by the standard deviation of 2.899, and that gives me a z-score of -2. Then, just like we did up here, we're going to go to table A to find the probability. The z-score is not the probability. So when I look on table A, I have a probability of 0.0228, or 2.28%. We're going to keep working on these throughout our next couple of topics, but hopefully this makes a little more sense.